Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about the sine graph. Now, a brief introduction to sine, cosine and tangent. We will be seeing these a lot in the geometry section. We will be talking at length about them, what they mean, etc. But just for now, we need to know the graphs of the sine graph, the cosine graph and the tangent graph. So I'm going to briefly explain where they come from, but in very little detail in order to come back to it in the geometry section. Now, these things originate from triangles, and in particular triangles with a right angle in them. So you need right angled triangles. That's a triangle with a 90 degrees in it. Okay, now they're all about an unknown angle inside the triangle. Say you were thinking about this particular angle here which you called x, and you didn't know that angle, let's say. Now, with reference to this angle you may be trying to work out or use, the side that is opposite that angle, we call it the opposite, and we would give it the letter capital O to represent the opposite. The side of the triangle that is beside the angle you're dealing with, we would call it the adjacent, and we would give it capital A. And the other side we call the hypotenuse. It's always opposite the right angle, it's always the longest side of the triangle, and we would call it capital H. Now, if you were to divide the opposite by the hypotenuse, the length of the opposite divided by the length of the hypotenuse, so say if this was, let's say 7 and that there was 12, if you did 7 divided by 12, it would always give you the same answer as if you did this sine function of the angle. If you did know the angle, if you did sine of that angle, it would always give you the answer, the same answer as if you did the opposite length divided by the hypotenuse length. And the sine is a button on your calculator, and it's this button here. Okay, that's the sine button. The one beside it is the cosine button, and the one beside that is the tan button. So it just so happens, it turns out that sine of this angle, if you work that out, it always gives you the answer to the opposite side, the length of it, divided by the hypotenuse length. And that's where this sine comes from, sine x. So we're always going to put in an x value in here, and we're going to get a number out the other side. So let's think of the sine graph by thinking of a table of values, like we always do. We always start by thinking what they look like by trying to do a table of values. Now, the x's I want you to put in here start at negative 360 and they go up to 360. I want you, using your calculator, and your calculator must be in degrees mode, I want you to work out the sine value for each of these angles, and then try your best to plot the graph on this graph paper. So pause the video and have a go. Okay, you would have got the following if you did that. Now, these are the answers you get when you work out sine negative 360, you get 0, etc. And I plotted all those points and I drew a smooth curve through it. And that there is the graph y is equal to sine x, like that. For x values between negative 360 and 360. There's a couple of things we should note about it. It looks like a wave. It's a wave type graph. You can imagine a wave like there. It always, at its maximum value is 1, and its minimum value is negative 1, like that. And on top of that, it seems to repeat itself every 360 degrees. You see this here? I'm drawing that over between where x is 0 up to x is 360. Now if I just pull this along, do you see it's the same shape between negative 360 and 0, and then it starts repeating itself between 0 and 360. In fact, for numbers bigger than 360 it will repeat itself again, and for numbers less than 360 it will repeat itself again. So that wave type look repeats itself. And that's the sine graph that you need to be familiar with and be able to know its particular values. Now let's talk about using it in more detail with the next example. So we are asked to use the graph y equals sine x, which is provided, to solve sine x is equal to 0. For x is between or equal to negative 360 and up to 360. So if we've got the graph y is equal to sine x, and we want to solve the graph 0 is equal to sine x, what we're going to do is we're going to let the y number here equal 0. So we're going to draw the graph y is equal to 0, which we know from many a time is just the x-axis, isn't it? So we're going to draw that graph in. It's going to be here, and that there is y equals 0. Now we're trying to find the points. Now there, the graph is equal, y is equal to 0. There, 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 and there. So the solutions in this case are, starting with the smallest x, x is negative 360, x is negative 180, x is 0, x is 180, and x is 360. They are our answers that make sine x equal to 0, and we're done. Okay, let's try another one. Use the graph of y equals sine x to solve sine x equal 1. Pause the video, have a go. Well, if I want to see where my graph y equals sine x is equal to 1, what I'm going to draw is the graph y equals 1. And that graph looks something like this. And I can see 2 points where my graph equal 1, here and here. And for what x values is that true? Well, just by reading down nice and carefully, it's x negative 270 and x equal 90 are my two answers. So here we have x is negative 270 and x is equal to positive 90 are my two answers, and I'm done. Let's try another one. Pause the video, have a go. To solve this one, I'm going to draw the graph y is equal to negative 1, and I'm going to see where my graph equals that. It's there and there, and we can see that these have solutions for x is negative 90 and x is positive 270. So clearly from our graph there we get the two solutions. X is negative 90 and x is equal to 270, and we're done. And two more for us to think about. Pause the video, have a go at this. Okay, for this one we're going to draw the graph y is equal to 0.5, 0.1, 0.2, 0.3, 0.4, 0.5, like here. Okay, and let's see where it crosses. It crosses there, 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 there. So there's going to be 4 solutions for this. Let's see if we can work them out. Now, let's just think. We've got ourselves 1, 2, 3, 4, 5, 6 squares giving us 90 degrees. So 6 squares represent 90 degrees. So halving that, 3 squares must be half that, which is 45 degrees. And if I divide that by 3 to work out what 1 square is worth, 1 square must be 15 degrees. Okay, let's do the easy ones. This one here is 1 square, 2 square across, so that must be 30 degrees. So I know one of the solutions is x is 30. Now this one here it's 2 squares back from 180. So 2 squares is going to be worth 30. So taking away 30 from 180, it's going to be 150, isn't it? So x is 150 is another solution. Let's try and find the other two here. Well, this is negative 180, so 2 more squares is going to go back another 30. That's going to be negative 210. So negative 210 degrees is another answer. And this one here, well, the way we can think of it, it's 2 squares forward from negative 360. So it's negative 360 add 30, which would be negative 330 degrees. And they are our solutions. Last one now. Use the graph y equals sine x to solve sine x is negative 0.5. Pause the video, have a go. Okay, I'm going to draw y equals negative 0.5. So let's give that a go. So it's going to be 0.1, 0.2, 0.3, 0.4, 0.5. It's going to be along here like this. Where are our solutions? Well, our solutions are here, 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 and here. And we draw ourselves some little lines up. That one, that one, that one, and that one. And the same rules apply here, with one square being worth 15 degrees and two squares being worth 30. So let's try and see what our x answers are. Again, there are 4 x answers for this. Let's see if we can count them in a quick way. This is negative 180. And we're going forward 2 squares, which is we're adding on 30. So the first one's going to be negative 150 degrees. What about this one? We're 2 squares to the left of 0, so we're going back 30. That one's going to be negative 30. This one here is 2 squares forward from 180, so that's going to be 180 add 30, which is 210 degrees. And this one here is 2 squares back from 360, so it's 360 take away 30, which is 330 degrees. And there you go, a very brief introduction to what the sine graph looks like and using it to make some simple solutions to some very simple equations. That's it. Thank you for watching.